Welcome, ladies, gentlemen, and all the other wonderful humanoids of the western spiral arm of the Milky Way galaxy. First, you design the solar, then you design the system. Step 3, profit. I think you mixed up a pulp culture reference and a meme there. Anyway, my favorite way, and I'd argue the best way, to design something is to take something that already exists and just modify it a little bit. You Earthlings should be familiar with your home system. What we are most interested in is how far away on average each planet is from their home star. So we'll be working in astronomical units. Reminder, a single astronomical unit is defined as the average distance between the home star and the planet with life on it. In your case, that's Earth. In our case, we're defining that as Concordia. Now, since Earth revolves around a nice yellow sun and Concordia revolves around a colder red dwarf, you cannot just copy and paste the distances between the two solar systems. If we did, our poor planet would be left out in the cold. Remember, we calculated last time, in order to be in the habitable zone and the tidal locking zone, Concordia would have to be placed not 0.14 AUs away from its home star. Bless you. Instead, we want to scale the Earth system smaller while still maintaining the proper portions. So just multiply everything by 0.14 to get the astronomical unit equivalent for our Concordia system. Do this for every planet in the Earth system and you'll have the proportional equivalent in the Concordia system. We've also indicated the inner and the outer habitable zones that we calculated last time. It can't be that simple. My fudge sense is tingling. You are justified in being a little skeptical of this method. After all, distance is a one-dimensional measurement, whereas things like solar mass and volume are a three-dimensional measurement. Not everything scales at the same rate. Take for instance a cube. If you double its side length, its volume actually goes up by 8 because it goes up by the cube. Not to mention that physical laws like gravity and luminosity scale by the inverse square of the distance. Hey, where do you get off multiplying the entire universe by a single scalar? Alright. I admit it. I didn't trust this answer either when I did it at first. I rationalized it to myself, saying we picked a sun that was 0.4 times the mass of Earth's yellow sun, and then used software to get an answer of not 0.14 AUs. Bless you. Those values obviously scale differently from one another, so I thought all the weird dimensionality between the units worked itself out there. Still, I was a bit concerned, so I got myself a second opinion. We checked out the recently discovered, at the time, TRAPPIST-1 red dwarf system and performed similar calculations. It's not hard to work out by hand, just multiplication and division. However, the results were really eerie at first. The proportions, as far as distance goes, map onto each other astoundingly well. We also found this chart right here that compares the luminosity of the TRAPPIST planet to the Earth ones. It has TRAPPIST-1c as an equivalent to Venus just inside the habitable zone. For us, in the Concordia system, that planet's Sparito. So after this comparison and many other ones, I figured our Concordia system was just fine. There are still some slight problems with this model, so maybe that's why you smell chocolate. For instance, we use TRAPPIST-1e as the Earth equivalent planet when the chart uses 1d. Also, we removed the Mercury and Mars planet equivalents and kept Jupiter through Neptune, even though TRAPPIST-1 doesn't appear to have any gas giants. So yeah, maybe all these masses at these distances come together as a system, it won't be stable, but I feel like our calculations and our results are all well within the FAR method, so I'm happy with them. I knew it. There had to be a catch. Another thing we used the LAR method on was to calculate the planet's density. Since mass scales with mass, it goes to reckon that since our sun is 0.4 times the mass of Earth's sun, all our planets are 0.4 times the mass of their equivalent planet. Now, density is the important figure when trying to figure out the planet's compositions. We want to know whether or not it's rocky or gaseous, or whether or not it has water. Though there are red dwarf systems with hot Jupiters, those being gas giant planets that are extremely close to their home star, it's believed that they formed on the outer rim of the system and moved inward. We wanted to keep the formation of our Concordia systems very similar to Earth, so inside the habitable zone we have rocky planets, Those are subject to solar flares that blow away most of their atmosphere. And then outside the habitable zone, we have gas giants. The solar flares at that distance are much weaker, so the planets are able to hold on to more mass. This creates a positive feedback loop, and so they're able to collect even more mass and become the planets that we know today. Now, I did something special with Concordia being it's our home planet, but we'll get to that a different time. For all the other planets, just find their equivalent planet's density. With mass and density known, you can easily find volume. And then with volume, you can easily find diameter. Just a nice system of equations. Recall this chart again that shows that the density as well as the size of the TRAPPIST-1 planets are equivalent to those in the Earth system. Multiplying by proportions again should be fine as long as we're careful about what dimension we are using. Now, I did this with my best friend Excel before I found this video by Artiflexion where he points us to this chart. Curious to double check my math, I plotted all my planets onto the chart, and again I was very happy with the results. For reference, this is Earth and Venus here. As you can see, our gas giants fit in well when plotted with the gas giants from the Earth system. Yeah, our inner rocky planet could be a bit rockier, but I'm okay with that for now. And since I did that special thing with Concordia, it ended up being a lot bigger than Earth, well outside the parameters given by that paper, A Habitable Planet for Man. It's even outside the less conservative parameters that Artiflexion gives in his video. But I had my reasons, and so I'm going with it. What we are really excited about is Concordia looks like it's dipping into the water world type of planet, and that is very good news for any creatures that want to live on our super Earth-like environment. We'll discuss all those features at a different time when we design the planet itself. Next time what we'll focus on is finishing up the design of the solar system by talking about orbits and their eccentricities. And that's a wrap! I can't believe you went with the sneezing joke again. It's called a callback. It's called annoying. Well, that's just how humor works. First the joke is funny, then the next time it's less funny, then it transitions into being annoying, and if you keep doing it, eventually it combines into a self-depreciating and self-referencing cocoon that morphs into a beautiful butterfly of hilarity. I hope that's not your rationalization to use it again. Never.